Welcome to this second webinar in a series of 3 webinars. This is a webinar about privacy by design for the total learning architecture. And this second webinar is particularly designed for activity providers who build TLA-based learning activities. Although it's going to be useful for anyone, but this is the particular audience to which I tailored these slides. A little bit about myself. My name is Dr. Bart Knijnenburg. I'm an assistant professor in human-centered computing at Clemson University. And my research interests are usable privacy decision support and the user-centric design and evaluation of adaptive systems. So, a quick disclaimer. This work has been supported by a DoD award for the Advanced Distributed Learning Initiative. However, the views expressed in this webinar are my own and do not necessarily reflect the views of ADL and DoD. So, the goal of this series of webinars is to inform TLA performers about the aspects, the operational characteristics of TLA that impact users' privacy concerns. Now, since TLA is still under development, we have a unique opportunity to develop it in a way that takes privacy right into account as we are developing the system. So this is a philosophy that is called privacy by design, and it's been shown to be one of the best ways of dealing with users' privacy. So in this webinar, I'm going to give you some recommendations on how to build TLA according to this philosophy of privacy by design. So to build it in a way that takes privacy inherently into account. Now, please note that the recommendations that I'm going to make today are tentative and subject to continued discussion and revision. So this webinar is not only an opportunity for you to learn about privacy by design as it pertains to TLA, but also to provide me with feedback and to discuss some of these ideas. So to that effect, I have Dr. Aaron Ash in the room who will be moderating any questions that are coming in. So if you do have questions, there's 2 ways to ask questions. One is to raise your hand, your virtual hand, and Dr. Ash will then interrupt me when possible and unmute your microphone so that you can ask the question. Or if you don't want to ask the question directly, you can also ask it in the chat, and then Dr. Ash will ask it for you. So, first, I want to start with some definitions so that we're all on the same page. I think most of you will already know these terms, but I want to just, before we do anything else, make sure that we have these clear. So the first definition, the total learning architecture, or TLA, that's a set of specifications for creating a learning management system that integrates learning applications into a personalized e-learning solutions. And it's this integrated part and personalized part that actually makes this so relevant, that makes privacy so relevant for the TLA, because we're integrating a lot of learning applications and using a lot of data to make learning personal. Now, privacy by design, as I mentioned, is a design philosophy in which privacy is addressed in the design of the system rather than after the system has been developed. Operational characteristics, I mentioned that word already once. What I mean by that is an aspect of TLA that influences the user's experience. And in this case, the operational characteristics are particularly those aspects of TLA that pertain to privacy. So I'm going to kind of cut down the idea of TLA into smaller pieces and talk about privacy by design for each of them. Now, please note that I'm not talking about any specific reference implementation of TLA, but I'm talking about the general idea of TLA. So some of these concepts may sound still a little bit out there, but I think it's important to already think about the privacy aspects of those future aspects of TLA. Personally identifiable information, or PII. So whenever you see the term PII on my slides, I mean information that reveals a person's real-life identity. De-identification is the practice of removing PII from a set of data. And pseudonymity is means to identify a person in a system without revealing any links to their real-world identity. So, for instance, a username that is not necessarily linked to your real name is a pseudonym that can be used in a system. So here are the topics that we're going to address today. These are the operational characteristics that we're going to look into. So first, we will review research on how users make privacy decisions. So the users are actually the first operational characteristic. And now these are not really under control of the system, obviously, but it's still very important to take users into account. So I'm going to give some examples also on how to best support users' privacy decision-making practices. Then we will consider the various considerations that we need to make regarding the collection of different types of data by the TLA data core. So when we're collecting data, how do we deal with that data, and what kind of data can we collect, and what are specific considerations that we have to make for each type of data. Next, I will address ways to effectively present recommendations and adaptations while avoiding privacy problems, because even when you're presenting these personalized learning experiences to the user, these personalized presentations may create some privacy problems as well. So how do we deal with that? Next, I'll discuss questions of data location and ownership, and also make a proposal regarding how personal data should be managed within the TLA system architecture. And then finally, I will talk about data sharing outside of the TLA. So for instance, sharing the data with the user themselves. What is the use of having the user inspect their own data? The dynamics of social learning, so sharing data with peers. The ethics of user research, so sharing data within the organization for research purposes, as well as for purposes of promotion and deployment. So we will talk about how we deal with privacy issues that might pop up when we're sharing data outside of TLA. So as I mentioned, this is the second in a series of 3 webinars. And this particular webinar is developed for activity providers who build TLA-based learning activities. The slides that pertain particularly to this audience are marked by this blue guy over here. So if you've been to the previous webinar on for TLA backend developers, you will see that there is quite a bit of overlap in slides, but the new stuff is anything that features this little blue guy. So as I mentioned, we recently had our TLA backend developer webinar. That was on Tuesday. The video of that will be online soon. And on Monday, next Monday, we will have a particular webinar for training department managers who will be managing a TLA-based environment within their organization. So if you listen to this webinar and you think, I want to learn more about this, well, this webinar is based on our first privacy specification document for TLA. And this is a 100-page report that can be found at the link that is listed there. At that site, there's also a 10-page summary version of that 100-page document if you don't want to read all the 100 pages. And I will post the slides of these webinars and the videos of the webinars onto that link, or at least a link to the videos on there as well. And it also contains some general information about the project and some contact information. But you can also contact me directly at bartk@clemson.edu if you have any questions or if you want to discuss more. So without further ado, let's start the webinar. So privacy issues are an undying obstacle to the real-world implementation of learning and training systems, and TLA in particular, because of this integrated and personalized nature. So while there exists a lot of privacy-preserving technical solutions, it's important to realize that the concept of privacy is a human attitude towards the collection, distribution, and use of disclosed data. And even the disclosure of that data itself is in many cases contingent upon a human behavior. So it's important to understand that the research on how users of information systems like TLA make privacy decisions. So in this section, I will review this literature and give you some examples on how to best support users' privacy decision-making practices. If you're following along in the specification document, this is actually a combination of section 1, which actually talks about the user characteristics themselves, and section 6, which talks about these privacy decision support mechanisms. So the first part of this section can be summarized into kind of 2 broad findings. And the first finding is that users are not categorically against disclosing their personal information. If the benefits of disclosure are substantial, then they will actually disclose their information quite freely. So people actually make a trade-off between the benefits and the risks or potential risks of disclosing their personal information. And this is called the privacy calculus. So people engage in this calculus when they're deciding on whether to give away their personal information. Now, the second part, though, is that users are not very good at this calculus. They're not always rational in making this decision. And because of that, circumstantial aspects, like, for instance, the default setting of a checkbox on a form, actually has quite a substantial influence on people's privacy decisions. So it's a combination of rational and heuristic decision processes. So that's depicted in a little more detail on this figure right here. So this actually synthesizes a lot of the research in this area. And importantly, when we look at the rational influences on disclosure behavior, we see that perceived risk and perceived relevance are the most important aspects that influence disclosure from a rational perspective. Now, when we talk about risk, people perceive risk when they have privacy concerns about a system. So it's our job as application developers to reduce those privacy risks. And I will talk in this presentation several times about ways of doing that. But it's important to also note that this is also contingent upon users' trust in the provider of these systems. So this is not just something that you can change overnight. If users already have a certain level of trust in you as a provider of a learning activity, then that trust actually plays a very important role as well. Now, on the relevance side, it's important to know that, as I mentioned earlier, people are willing to disclose personal information if it is relevant. And you can improve the perceived relevance by highlighting the benefits of disclosure. So if you tell users why you are asking for certain information, that's a really good way of increasing that perceived relevance. And that can overcome some of those problems with risk. Now, aside from these rational influences, there's also heuristic influences, as I mentioned. So these heuristic influences are, for instance, the context of the decision. So, for instance, Facebook is a good example of a system that gives a lot of privacy options, and paradoxically, because it gives so many options, people end up disclosing more, even though you give them more options to manage their privacy. So that's kind of a heuristic influence there. Another one, as I mentioned earlier, is the default setting or the default order in which you ask certain questions. That really influences how much people disclose. And finally, there's affective heuristic influences. So whether you frame a certain information disclosure as either a loss of privacy or a gain of benefits, that really affects their decision as well, even though the rational trade-off is the same. So for app developers, it's important to act as a trustworthy source of learning experiences. And such trust can be established through sensible, well-reasoned data collection practices, and communicating those practices to users is one of the things that we'll be talking about. How do you do that effectively? Now, this perception of trust can be improved by highlighting the relevance of the information as well, right? So, for example, if you have a language training app, you can ask the user to import all kinds of external information. But if you tell them, oh, if you import your Duolingo data, you can skip lessons about phrases you already know, like that's a really nice way of highlighting the concrete benefits of disclosing this personal information. So, as I mentioned, there's both rational and heuristic influences on decision making. And it's interesting to see why that is the case. Why are there both rational and heuristic influences? Well, it's because people actually make either more or less elaborate decisions. And this idea is represented by the elaboration likelihood model. When people are in central route processing, they are more influenced by these rational influences, whereas if they are in peripheral route processing, they are more influenced by these heuristics. So central route processing, people tend to make an effort to understand the true risks and benefits of disclosure. They really try to understand what's going on. And so if you want to get them to disclose more, you should have a good privacy protection mechanism, and maybe explain how you're collecting the data using a privacy policy. So an app that provably behaves trustworthy will really help people in the central route to overcome these problems of risk and relevance. Whereas in the peripheral route, that's where these heuristics really play a big role. So in this case, people make quick and heuristic decisions that are based on usually superficial aspects such as privacy guarantees and the design quality of an app, or the reputation of the website that is presenting the information. So in this case, it's important for an app to look trustworthy, because people are actually not going to take the effort to learn more about it. So for the central route, you need to behave trustworthy. For the peripheral route, you need to look trustworthy. So it's important for TLA to help TLA users with their privacy decisions by really catering to both of these routes. If you engage in central route processing, then a good privacy control mechanism and helping users to control their privacy at the desired level is a really good way of doing that. But for peripheral route processing, giving people a lot of control is not going to actually help. For them, it's better to have some sensible default settings, and if the user has to make a decision, to really explain it in a very short and simplified way, because if you give them a privacy policy, they're not going to read it. So another thing we can think about is how can we get people how can we encourage people to actually use central route processing, to be more rational about their privacy decisions? Now, it turns out that this is possible because people are more likely to use the central route if they feel able and motivated to do so. Now, how can we increase people's perceived ability and motivation to take the central route? I have two examples for doing that, and there's many more also in the document. So the two examples here are contextualized controls and comic-based information. So contextualized controls, this is an example from a study where we tested form auto-completion tools. So this is the feature where you start filling out your name and the tool automatically fills out the entire form for you. So this is notoriously bad for people who use the peripheral route, because as you fill out everything, it makes it very easy for people to skip weighing the risks and benefits of each piece of information and just scroll to the bottom and press submit. So to overcome that problem, we added a little button to the end of each field, a toggle that allows them to add or remove the information to or from that field. And so adding that button doesn't add a lot of additional functionality, but it does show people, it does make them feel more able and more motivated to actually make these privacy decisions. So it reminds people, I should probably look at these things in a little more detail. Similarly, when we talk about giving people information about privacy, even people who are most rational about their privacy decisions often don't read their privacy policies because they're typically too long, too complex, and just boring. So a way to overcome this problem is to turn the privacy policy into a comic. And this is some research that we're currently working on. We're trying to turn some privacy policies into a comic because we believe that comics are more engaging. They retain users' attention longer. It's also easier for people to memorize what they read in the comic than what they read in a long piece of text. And we hope that it also helps people to kind of single out pieces of the text by just looking at the comic from a distance that they are most interested in and where they actually want to spend their effort. So again, we believe that this increases people's ability and motivation to act more rationally. So now we've talked about more the information privacy aspects, but in the spirit of social learning, TLA-based systems may also have social networking components built into it. And so there's specific user characteristics when it comes to social related privacy. For example, one thing we have found in our research is that there are generally two types of social media users. There are FYI communicators who tend to like passive, asynchronous, one-to-many communication services. So things like Facebook or Twitter or location sharing services. And on the other hand, you also have non-FYI communicators, and they tend to like active, synchronous, and one-to-one communication services. So services like WhatsApp or Skype or just a regular old telephone. So you have to tailor to both of these types of users. But even within a single type of social media or social network, there tends to be a lot of different ways in which people can use these systems in a private way and in which they can manage their personal privacy. And people generally don't actually engage in all these privacy mechanisms, privacy protection mechanisms at the same time. They tend to employ these mechanisms selectively, and we have been able to detect privacy management strategies based on these behaviors. So here's an example of that. This is we did some data analytics on the privacy behaviors of several hundred Facebook users to show that there were actually 6 profiles detectable within those several hundred users. So aside from maximizers, the blue line here, who tend to do a lot of everything, and minimalists who tend to not deal with their privacy a lot, we see a group called selective sharers, the red line here, who tend to share quite a lot, but are very careful in who they share it with. On the other hand, you also have self-censors, the light blue line here, who tend to share with pretty much everyone equally, but they're very limited in what they share. Now, aside from that, we also have time-sharers, the purple line here. They're people who focus more on consumption privacy. They do a lot of Facebook reading, and they want to make sure that they're not overwhelmed by messages from other people, so they turn off the chat or they tailor their timeline. And then finally, privacy balancers, who do a little bit of everything, because you still have those people as well. So that's how people interact with systems like TLA, both on the information privacy level and the social privacy level. And so we've talked about how people disclose their personal information. But what personal information are we talking about here? How is data being disclosed or collected? And what are the considerations that we have to take into account regarding each type of data? So that's what we're going to talk about now. And again, if you're following along in the specification document, this will be section 2 of that document. So it's important to note that privacy does not just relate to personally identifiable information. It's not just your name and your email address and your social security number that is private information nowadays. In fact, even when data is de-identified, there exist mechanisms to re-identify its owner. For example, Netflix a while ago released a completely anonymous data set of people's private Netflix viewing preferences, and researchers were able to cross-link this data with public and identified IMDb viewing information. And so by cross-listing different user profiles, they were able to re-identify some of these private profiles. And this actually ended up outing a closeted gay mom. And she ended up suing Netflix for several $1 million. So that was a big problem. Similarly, people can be easily re-identified using a subset of their friend network. So by just knowing who your friends are, it's fairly easy for me to re-identify you. So protecting users from these kinds of attacks is especially important for military applications, because it can prevent revealing secret identities and locations, as well as prevent things like blackmailing and spear phishing from happening. So it's important to make sure that data is completely anonymous. And that means that a system needs to go beyond pseudonymity. Just having usernames and no real names attached to the data is not enough, because the data can be re-identified. So instead of that, or beyond that, systems need to employ methods like differential privacy and homomorphic encryption to make sure that the data is completely anonymous and that they cannot be linked back to the real person. That's the only way to ascertain full anonymity. Now, that said, full anonymity is not always necessary, and even pseudonymity may not always be great. Now, pseudonymity is very useful in certain cases. For instance, when you want to foster creativity or intimacy. And that happens quite a bit in learning. So for instance, if you have a learner forum where users might fear some humiliation for asking silly questions, then pseudonymity might help them by kind of shielding them from real-world repercussions for asking those questions. At the same time, though, there are definitely situations where real name policy is preferred. So for instance, research suggests that using users' real identities in online systems actually reduces fraud and anti-normative behavior. So this could be useful in formal settings or diplomatic settings, like conducting a formal training or a joint military training between several forces, because their real identities will likely reduce things like trash talk and unfair behavior. So in that case, maybe a real name policy is actually better. So another thing to talk about is the fact that TLA does not just involve conventional learning and training. It's the vision of TLA that users are expected to receive credits for experience gained outside of formal learning experiences as well. So if you're reading an ebook or if you're watching an important documentary, you should be credited for learning at that point. Now that means that there is only a fluid boundary between learning and a user's other activities. And that means that TLA may collect all sorts of behavioral data more or less on the fly, like maybe fitness tracking or reading behavior or psychological well-being or financial health. So each of these different types of data really has its own unique privacy implications. And this webinar is unfortunately too short to go into the detail of each of these, but you can read that in our document. You know, one thing that I'll say about it is that it's really important for users to be able to consider their privacy settings for each of these different types of data separately, because not every type of data is equal in the user's mind. So another type of data that I want to single out here is runtime activity data. This is the detailed account of activities during a training. And so this is what learning activities would send through the data to the data core through the X API. And I would say that this is arguably one of the most sensitive types of data, not individually, but on aggregate, it can be very sensitive because it may reveal all kinds of technical details and team weaknesses. And so those data should never fall into the wrong hands and should never be used for nefarious purposes. So it's very important to de-identify, obfuscate, and probably even encrypt that kind of data. So make sure you protect that data. But when possible, certain data, I believe you shouldn't even collect at all. One example of that would be medical data, because if you collect medical data, you're automatically bound by the HIPAA law, the Health Information Privacy law. And so you have to be very careful with collecting that kind of data. And in many cases, you have to think about, do I even want to collect this data? Is it possible for me to use the data server side, client side, rather than collecting it on a server? Now, more generally, I want to say that you need to learning activities should not track the users too excessively. So if tracking is not necessary, it's probably best not to do it. The one situation you want to avoid is that users believe that they're constantly being tracked. That's really bad because it may have a real chilling effect on their sense of freedom and their sense of exploration in the system. Now, this is called the panopticon effect, after a circular prism designed by Jeremy Bentham. I have a figure of it right here. So in this prism, inmates know that they can be watched at any time, but they don't know when they're being watched because they cannot see the watchman. But because they always know that they are potentially being watched, this has a very limiting effect on their behavior. Now, that feeling of always knowing that you might be watched is something you don't want to create in a learning environment. So I'll talk later on in this webinar about how you can prevent that from happening. So on the other side of the coin, I must say that if users want to include certain data within TLA, it's a good idea to do so. So TLA-based systems should, for instance, encourage users to submit outside data, such as their learning ambitions, to the system, because that will really help the system leverage things like intrinsic motivation. So even though that's typically not part of a learning system, collecting the data can be very useful and actually have a positive influence. Also, TLA-based systems should allow users to selectively add competences that they've earned outside of the TLA, because users are likely going to be proud of that, and they're likely wanted to actually have that data as part of TLA. So they should be enabled and encouraged to do so. So, as I mentioned, if you are continuously tracking the user, it's really important to prevent this panopticon effect by making the users aware of what is being tracked and, most importantly, also when. And that they have control over this, that they can turn that off if they don't want it. So TLA-based systems should provide users with an easy-to-use notice and control mechanism. So one example of this could be some kind of control center widget, like the Apple Night Shift widget, but I've made this now work for TLA, where basically the system kind of automatically turns on and off based on the user being on the clock or off the clock, and users can manually override that by pressing the button and turn tracking on or off manually as well. Another example here is a notification when tracking is available, with an easy button to turn it on. So if I'm reading an ebook that might be considered learning, a little pop-up could show up and it could allow me to track this activity as part of my learning experience. If you want to be a little more forceful about that, you can also turn this around and start the tracking automatically, but still allow the user to stop it if they don't want this activity to be tracked. And if you want to make sure that users make the correct decision, so you want to overcome this default effect, you could force them to make a decision by giving them a modal pop-up and not allowing them to continue until they pick one or the other option, tracking or not. And then finally, if you are tracking the user, it is a good idea to actually show them that you are tracking them. So a little bar at the top that says I'm now tracking your learning activity is really useful for users to have this awareness of when tracking is on and when it is off. So TLA tracks information so that it can make inferences about the user's learning performance. And those inferences should be treated with care as well. Specifically, users really hate incorrect inferences, even when they are non-consequential. If a system assumes something about them and it's wrong, they typically don't like that. So if a certain inference could be wrong, it might be better to just ask the user for confirmation rather than just acting upon the inference right away. Now, even correct inferences can be problematic because users may find them creepy or they may feel like they're being overly stereotyped. So explaining the inferences can actually help reduce this creepiness. And when I talk about stereotyping, it is true that inferences can create a potential for discrimination. So you have to be very careful when you're using TLA data to not discriminate against certain groups of people. So for example, if you are doing a lot of computerized tests, it has been shown that females are worse at computerized tests than at paper-based tests, and there's no such an effect for males. So if you base a lot of your decisions on the answers to computerized tests, you might be discriminating against females. So you need to be very careful about those things. Now, the best way to avoid unwanted inferences is to allow the user to inspect and correct them. So Google, for example, allows users to see what topics they have inferred about them from their search and Gmail history. And these topics are then being used for targeted advertisement. So you can actually go into Google and you can actually see these topics and you can turn them off or on, and you can turn ad personalization on or off altogether. But this kind of scrutability, as it's called, is very useful. All right, so now we've talked about the TLA or TLA-based systems collecting a lot of data from their users. And the goal of all this is to provide personalized learning experiences. But to do this, these systems need to make on-the-fly recommendations and adaptations. So similar to data collection, these recommendations and adaptations themselves may sometimes bother the user. And in this section, I will address how to effectively present recommendations and adaptations while avoiding privacy problems. And if you want to get more details about this, because I'm going to go through it quite quickly, you can find more details in section 3 of the specification document. So the TLA specification talks about 3 types of adaptations. We have meta-adaptations, micro-adaptations, so meta-adaptations, macro-adaptations, and micro-adaptations. So meta-adaptations are personalized recommendations on what learning activity the user should engage in next. So for instance, you should train your French. That's the activity you should do next. Macro adaptations are recommendations of what to do within a certain activity. So for instance, if I'm in the French app, it could say you should work on your irregular verbs. And then finally, micro adaptations are small adjustments to the activity based on some contextual information. So for instance, if the system knows that you're going to go to Montreal in the next couple of weeks, then this French language app might add some local idiom to your training experience to help you along. So adaptations in general have a lot of benefits because they can reduce choice and information overload, right? If I have a learning system that is a portal to potentially hundreds of learning applications, it's good that there is a meta-adaptation that can tell you what to do next. And they also make it easier for users to find content and to find providers that fit their needs. And for application developers, adaptations create a sustained relationship with them. In fact, Netflix actually considers the recommendation algorithm to be one of its most important assets. So it's really a way for you to bind yourself to the user. But on the other hand, adaptations tend to focus on the user's current desires rather than their future goals. And this means that they can create filter bubbles. So they kind of prevent users from exploring new learning experiences that go beyond these recommendations. And finally, users can even become overly dependent on TLA or on these adaptations, and that makes them feel like they no longer play an active role in deciding what to learn. So we need to overcome those problems while retaining those benefits. So how do we do that? Well, one important thing is to provide really multi-purpose adaptations. So recommendations can be made generally, or to support tasks or higher level goals, or for kind of exploration, trying out new things, to fulfill some organizational need. And all of these purposes should be considered in deciding what to recommend next. And in fact, it might be good for users to be in control of this, to say, now I want to explore, now I want to do what my boss wants me to do, now I want to follow up on something that I've done earlier. And so an overall goal here is to support what I call self-actualization, is to not just supplant the user's decision on what to learn next, but to support them in their own journey of deciding what to do next and what to learn. So if you want to do this, explanations can really help in creating kind of an acceptance for recommendations. Because as I mentioned earlier, some of these recommendations might not be for the benefit of the user, but maybe for the benefit of the organization. And so explanations can really help explain to the user, this is why we think you should learn this right now. On the other hand, you have to be careful with that, and because those explanations can be a little pushy, so you don't want to go too far with it. It's always a good idea to give the user options. So even when you give them a recommendation, to allow them to say, what else do you got? What else is out there? And that really helps with this idea of self-actualization eventually as well. So here's an example of how explanations could be used within the TLA. This is an action card that not only gives recommendations, but also gives an explanation on how using a conversational tone that users can connect with. It's really an unavoidable design also, so that's kind of nice. It does give, it does persuade the users to set some goals within the recommendations. And it also gives transparency. It really transparently explains to the user who the recommendation, how the recommendation was chosen. And in this example, let me see. So in this example, you could say, well, I want to study, or I want to explore, or I want to stay sharp. So there are different ways in which you can decide what you want to do next. And these are these different goals of learning, so to say. All right, so that's kind of like how do we present the content of the recommendations. There's also the modality. So users can receive recommendations and adaptations on various devices, right? So when we use personal devices like a phone or a watch, we need to make sure that those recommendations are carefully timed. So don't interrupt the user in their current task. That's very important. Maybe a smart, silent, or do not disturb mode could really help avoid intruding upon the user's privacy. And to give you an example, Apple just announced that in iOS 11, they will have a don't disturb me while driving option. So something like that is great, where if we know that the user is engaging in another activity, don't give them a learning recommendation. Wait until they're free. When you're presenting recommendations on a larger or a more public display, like a computer screen or a TV, you also have to be careful not to show the recommendations when there are potentially bystanders, especially when those recommendations could potentially be something personal or something with classified details or something embarrassing. So be careful about displaying recommendations out in the open, because there might be bystanders who can see them as well. All right, Now we move to the topic of data location and ownership. So TLA-based systems collect a large amount of information, but where does that data all go, and who owns that data? So in this section, we will discuss questions of data location and ownership, and we'll make a proposal regarding how personal data should be managed within the TLA system architecture. So more details on this can be found in section 4 of the specification document. So this is abstraction of the TLA architecture as it pertains to data collection and storage. So this is not the TLA architecture, but it is kind of an abstraction with the information that is relevant to us. So there are 3 important components here. One is the TLA data core, which stores all the information. Then there's the processors, which use the information to provide adaptations. And then there's the user-facing apps. They also do part of those adaptations, and they also end up collecting the information because they are the ones interfacing with the user, right? So given these 3 types of adaptations, which component should be responsible for which type of adaptation? Because we talked about this idea of meta, macro, and micro adaptations. So I believe that the TLA processors should be responsible for meta adaptations because these adaptations require a knowledge of the user's overall learning profile. And I don't think that apps themselves necessarily need to be responsible for this aspect. It's the overall architecture that should decide which application should be activated next. Now, the processors can also do the macro adaptations, so adaptations of what will happen within each app. But I think that there are definitely application developers or activity providers out there who would say, well, that kind of decision requires some internal knowledge that we have as an application to decide like what is going to happen next. So I think that that part of the adaptation is actually better suited for the activity providers themselves, although I could see some kind of a combination of the two. And then finally, I strongly believe that when it comes to micro adaptations, it might be better to do those client side, to not do them either in the app or in the processors. Because these micro adaptations are usually the adaptations that make use of the learner runtime data or sensitive contextual information. And so it's better not to store this data on a server because it can contain all kinds of private information about the user. So rather than running those things server-side, it might be better to run them on the client, these micro adaptations. And most devices are currently powerful enough to be able to provide quite a bit of machine learning capability that these things do not have to be done server-side. So to translate that into the TLA architecture, it means that I want to use context data on the client side as well as learner, like the very detailed learner runtime activity. I think that data can still be stored, so here I crossed out the context data altogether. I think that's a little too much on the nose, but I think that if you want to collect that data server side, it's better to do that in aggregate. Same with the learner runtime activity. That still allows it to be used for things like research and other more meta activities. But the really detailed nitty-gritty data is better to use that client side, I think. Now, another change that I propose is the introduction of some kind of formal access control mechanism that gives user-facing apps potential but not unfettered access to the learner facts and the profile. So I want to kind of regulate that that access. So we're currently working on usable interaction mechanisms for users to manage access control, and I think users should be asked for permission to access data from the TLA data core. And I understand that, especially given the peripheral processing that a lot of users do, that'll be difficult. And so I'm looking into usable ways of doing this that I will discuss in a little bit. And one way to do this is through um, user-tailored privacy. So you can do user-tailored mechanisms where you actually allow a system to predict what users' privacy preferences are and then tailor the access control matrix based on that. Now, that's actually the topic of the second part of our project that we're currently working on. So there will be another entire document on that topic and hopefully a series of webinars as well. I also think that it's important to really store minimal amounts of data and to de-identify the data as much as possible. So that really reduces liability. You do not want the data to be accessed. If possible, you don't want the data to be accessed. And if it is accessed, it should be useless for anyone outside the system, if possible. So not storing the data in the first place is kind of the best possible prevention solution, I would say. But the identification will also definitely help. All right, so TLA users' data can be owned by multiple entities at once. And that's another thing that I want to mention here, is that when a user does a training activity for their job, then both the training provider, the employer of the user, and the user themselves all become kind of stakeholders in the collected data. And so the TLA needs to somehow deal with this concept of shared ownership. So how do we do that? Well, it's really difficult for users to really take active ownership of their data all the time. So even though I think users should be kind of the final owner of their data, I think that they should be able to delegate some of that responsibility to what I call a data steward. So this concept of data stewardship, another entity like a training department manager can manage the data on the user's behalf. So the user does not have to make these decisions themselves. Now, this is kind of a fiduciary responsibility that the data steward would have. And so there needs to be some kind of an agreement between the user and the data steward. Finally, it's important to also realize when it comes to ownership that users may move between different instantiations of the TLA. And so data mobility is very important as well. So I think that data ownership can be structured kind of like a 401k, where the user is the formal owner of the data. The employer can manage and contribute to it, again, with kind of a fiduciary responsibility. But the data can also move when the user changes employer or division. So this is kind of how that will work. It means that the user models will have to be somehow portable. And when the user moves to a new employer, some of their data will be transferred. Now, some of it will also remain hidden because it might be that some of the, for instance, if you move from a military to a civilian employer, some of the training data may be classified. So there must be a mechanism to account for that. The first employer will still have access to the data that was collected there, but it will not have any access to new data that is being collected. Now, it's also important that the user may not transfer all the data from their first employer to the next one. So they may want to say, I don't want to transfer all the things that I've learned. So the final part of this webinar, we have a couple of minutes left. The final part of this webinar discusses how TLA data can be used and shared within an organization, so outside of the TLA itself. So we consider the value of inspecting your own user data. We talk about the dynamics of social sharing and a little bit about the ethics of user research. And also using data for employment decisions based on training data. So for more details on this part, this is actually section 5 of the specification document. So when it comes to data sharing, users themselves should be the first and foremost to have access to their own data. Even outside of the context of training, they should be able to go in and check on their data. If you present the user's data in an understandable manner, it can increase their trust and their understanding, as I mentioned earlier, this concept of scrutability. And if you present it with a nice visual display, and then it can also help them, can create kind of a powerful quantified self experience where users can learn about their own training, and that really increases their kind of this self-actualization idea of personalized training. So users can explore data patterns on their own, and it would help them discover what makes them effective and what they need to work on. So another sharing opportunity is through social learning, right? And research has shown that learning together really improves learning performance, but it can also lead to privacy problems. So since social learning is a relatively private experience, social learning apps should not just simply share the learning outcomes with anyone in the user's social network, but instead they should allow users to selectively decide who they want to share with. So the app can even help with that selection and suggest sharing learning experiences with friends who have very similar performance. And it's better to also pair users with who have a similar communication style. So you put people who have an FYI communication style together, and you put people who like more direct communication also together. So another useful trick is to pair users in a way that leverages findings from social psychology. So researchers have found that some people perform better when they compare themselves against people who perform better than them. So this is called upward social comparison. And other people perform better when they are compared against people who perform worse than them. So downward social comparison. So if you want to create pairs of learning people, one way to do it is to put people together, one person who does upward social comparison and one who does downward social comparison. That really reduces the social friction when people might get competitive, for instance. Now, when you're sharing information between learners, it's really important to state that there are state and federal laws that may prohibit automatic sharing of, for instance, performance data and, as I mentioned earlier, health data. So users may have to give their explicit consent before you send any information to another learner. So educational privacy laws might play a role here, like FERPA. One typical aspect of social learning is peer assessment. I wanted to mention that separately. So feedback from peers can motivate performance, but overly extensive peer review procedures can actually be counterproductive. So there are both drawbacks and benefits to anonymity in peer review. So we could maybe make the peer review anonymous or have it open, but it's difficult to decide what is best, because if you make it anonymous, people are typically more honest, but also more harsh. So secret and snide comments can create kind of a negative atmosphere. So that's not the best. And I think a good way to foster discussion on this topic is to allow users to reply to the peer review evaluations in a somewhat more formal manner. That will actually help overcome some of these problems. So performance data collected within the TLA can not only be used to improve learning, but also for research and to decide on promotions or to plan missions. And the secondary use of information, it may not be expected by the user because they feel like they're using a training application. They don't know whether that data is also being used to assess them at a higher level. So users may, for instance, insist that some of these data does not really completely represent them, and that promotion and mission planning decisions need to be made on a more kind of holistic level. So it would be useful to do this kind of, to do any kind of activity like this, also research, through the use of consent forms or IRB-related procedures. And in some cases, it's better to require users to opt into some of these activities rather than allow them to opt out. So finally, administrators could give users a say in the development of the procedures surrounding this secondary use of their information. So get early buy-in by kind of telling them what you're going to do with the data. So that concludes the last session of our webinar, and now let's review what we have learned. So in this webinar, I've provided some recommendations that will allow ADL and other TLA performers to select the operational characteristics and really tailor the operational characteristics in a way that best alleviates users' privacy concerns. Unfortunately, I've only been able to give you a brief overview, and we're already kind of over time. So our first specification document, which you can find online, will have much more detail regarding each of these recommendations. And as I mentioned earlier, these recommendations are still tentative, so please read the document, the specification document or part of it, and tell me what you think. I want to foster a continued discussion about these issues as we move forward, and eventually I'll come knocking on your door for feedback. So please see this as an opportunity to discuss. So to sum up, in general, our recommendations covered the following topics. First of all, how to best support users' privacy decision-making practices, what considerations we need to be made regarding the collection of various types of data, how to effectively present recommendations and adaptations while avoiding privacy problems, how personal data should be managed within the TLA system architecture, and how data should be shared with people involved in TLA and in a responsible manner. So that's all. As I mentioned in the beginning, there will be separate webinars. There has been already a webinar for the backend developers, and there will be another one for training department managers on Monday. Also, the web address will give you the privacy specification document as well as a 10-page version. And feel free to email me if you have any questions. I thank you very much for listening, and I will now open the floor for questions if there are any. Feel free to raise your hand or type the question in the chat if you have any questions. No questions? Right? Oh, no? All right. Well, again, thank you all for listening, and I hope you enjoy the rest of your day. Feel free to peruse the specification document, and if you have any longer questions, feel free to ask them. Thank you.